Lesson 10.2.2 Executing the chi-square test for independence in two-way tables. This is a follow-up to the previous lesson, and we're going to start to learn some calculator shortcuts for everything that we did then. In Lesson 10.2.1, you examined how a moviegoer's science fiction knowledge level might be associated with that person's opinion of a science fiction film. The moviegoer's science fiction knowledge level was self-reported in a survey. For movie-making companies, it is important to know whether a movie is more or less popular among certain groups. In the case of the science fiction film, the variable we examined was self-reported science fiction knowledge level. This is called a demographic variable. Up at the top, a demographic variable contains information about personal characteristics of people as subjects in a study. There are other demographic variables and associations that a movie company might be interested in. For example, some movies may have more or less appeal among certain age groups, among members of certain political parties, and so on. Suppose a movie company released another film. This film was on a politically controversial subject that caused people to argue or debate. The movie company conducted a survey of a random sample of moviegoers, similar to the one described in the previous lesson. However, in this case, the company did not ask about science fiction knowledge level. Instead, this survey asked respondents, moviegoers, about their political affiliation. The three possible responses were Democrat, Republican, or other/unaffiliated. The movie company wanted to investigate whether the popularity of the film was related to the political affiliations of the moviegoers. A table like the one below might appear in a report summarizing the results of the survey. So here in Table 1, Political Film Survey Responses, we again have columns for response, yes or no, and now the rows are political affiliation. First row is Democrat, second is Republican, third is other/unaffiliated. We see inside all of the cells the individual answers, and then we also see totals on the side and at the bottom. So our analysis method, again, is the chi-square test for independence. A chi-square test for independence is a hypothesis test that tests the independence of two categorical variables. To carry out this test, we use a two-way table. The chi-square test for independence investigates the claim of independence between the row and column variables in a two-way table. So again, what are we doing with these tests? We are testing a claim of independence between the row and column variables in a two-way table. The steps for this test are very similar to the steps in the previous hypothesis tests that you have performed. Just as a reminder, off to the right, when two variables are independent, the outcome of one variable has no effect on the other. So with our steps in the hypothesis test, we have the null hypothesis. For a chi-square test for independence, the null hypothesis states that the row and column variables are independent, meaning they are not related to each other. So there's no symbolic form of the null hypothesis. It is just this sentence. And then the alternative hypothesis is just quite literally the alternative. The row and column variables are not independent, meaning they are related. You could say not independent, you could say dependent, but again, something that has the same idea. Number 1, for the political film survey example, state the null and alternative hypotheses in sentence form. Hint, use the specific names of the variables as previously described. So we don't want to just say the row and column variables are independent. We want to actually say what are the variables. So the row variable is political affiliation. So we can say political affiliation. And for the columns, response. So those are our variables. Political affiliation and response are independent. And then for the alternative, H sub A, we just say political affiliation and response are not independent. So conditions. The conditions for a chi-square test for independence are the same as those for a goodness of fit test. First, the sample must be a random sample, and then all expected counts must be at least 5. As you saw in the previous lesson, in a chi-square test for independence, the expected count for a combination of a row variable category with a column variable category is as follows. Expected count is equal to row category total times column category total divided by grand total. As before, when calculating expected counts, the expected counts are non-integer values. This means that they tend not to be whole numbers. You should generally not round expected counts to whole numbers. So we just want to keep that in mind. Do not round expected counts. Also note that the sums of expected counts should equal the row and column totals, respectively. This means that the sum of your expected counts for a given row should equal the row total in your sample, and the sum of your expected counts for a given column should equal the column total in your sample. Number 2, for the political film survey previously described, compute the 6 expected counts and record the counts in the table below. The first expected count is already presented in the table. These counts are based on the assumption of independence between the variables political affiliation and response. Make sure that the 6 expected counts are all greater than or equal to 5. Verify for each row that the sum of your expected counts equals the row's total. Verify for each column that the sum of your expected counts equals the column's total. Expected counts for the political affiliation data we are now going to write in this chart. So they've already done yes. Notice that they took the row total for Democrat, multiplied by the column total for yes, 72 times 120, and then divided by 200, which was the grand total. So now I'm going to do the same thing for the no's. So I'm going to get this entry. I have to take the row total for Democrat, again, 72, times the column total for the no, which is 80, and then I have to again divide by the grand total, which is 200. So 72 times 80 divided by 200, and that gives me 28.8. And now as a way to check, take 43.2 and add 28.8. Notice you get back to 72. Okay, so now let's do, going back to the yes column for the Republican row. So here the row total is 67. So 67 times the column total, which is again 120 for the yeses, and then divide by 200. So 67 times 120 divided by 200. And that gives me 40.2. So now for the no's in that row, the row total for Republican is 67 again. And now going back to the no column, that's 80. So 67 times 80, and then divided by the grand total, which is 200. So 67 times 80 divided by 200, 26.8. And then now check our answers. Republican 40.2 plus 26.8. That does take us back to 67. So now for the last row, other unaffiliated, I take the row total 61. And since I'm in the yes column, then I have to multiply by 120 and then divide by the grand total, which is 200. So 61 times 120 divided by 200. You get 36.6. And then finally, for the same row for other unaffiliated, take the row total of 61, multiply by the column total for the no's, which is 80, divided by the grand total, 200. 61 times 80 divided by 200. And that gives us 24.4. And if we check the row totals, 36.6 plus 24.4 does take us back to 61. And then while we're here, we can check the column totals also. 43.2 plus 40.2 plus 36.6 in the yes column does add up to 120, and then 28.8 plus 26.8 plus 24.4 in the no column does take us back to 80. So now we have our expected counts. So the next step, if you think of what we've done so far, we've got a table that has the observed responses because that came from a sample. And now we just calculated the expected table. So now it's time to calculate the chi-square test statistic. In lesson 10.2.1, you learned how to compute the chi-square test statistic for a two-way table. Number 3, compute the chi-square test statistic for the political film survey by filling in the following table. Compute the step 3 calculations to 3 decimal places. So right here, we are not going to do this. We are going to use our TI 83 or 84 with the observed and expected data. So we're going to switch over to the calculator and we're going to see how to enter all of this in. So on our TI 83 or 84, we're going to use a new function that we haven't used before. We're going to be putting all of our numbers into what's called a matrix. So first press the second button, and then press the button that has an X with a -1. It's 3 buttons down, and it has the word matrix above it. So if you press second and then that button, that's going to take you to the matrix screen. So when you press that, you'll see a new screen that has this, names, edit, and math in front of you. What we want is the edit part. This is just like when we edited lists. So you'll use the right arrow on the direction pad to go over to edit, and then you want to highlight matrix A as the first one, and then press enter. Now we need to change the dimensions of the matrix. This goes along with what we have in the table. So if you look at table 1 for political film survey responses, you'll remember that we have 3 categories in the row: Democrat, Republican, and other or unaffiliated. So the first number in your matrix dimension needs to be a 3, matching with that. So you can see that it's blinking on 1. You just want to type a 3 there and then push enter. And then for the second number, this goes along with the number of columns. For our response variable, we have 2 choices, yes or no. So we have to type a 2 for the second number for the matrix dimensions. So type 2 and then enter, and now you can see you've got 6 entries that we need to fill. These correspond with the 6 entries that we have on the inside of our table. So the first row, first column goes along with Democrat that answered yes. So the first entry there has to be 49. So you can just type 49 and then press enter. Remember, this is coming from the observed values. Then the next entry stays in the first row for Democrat, but now it's the number of no's. So for that entry, you're going to type 23 and then enter. Now you're down to the second row for Republican, and now this entry is for the number of yeses. So Republican yes was 37. Then enter, and then the next entry is Republican no, that's 30, type 30 and enter. Now we're in the bottom row for other/unaffiliated. Number of yeses for that row was 34, and then finally number of no for that row was 27. So now we've got all of our observed values in matrix A. So now, as you might expect, we need a matrix for the expected values. So now we're going to go back to the matrix menu by pressing second and then the X with the -1 button that has the word matrix above it. That takes us back to the matrix menu. We again have to go 2 over to edit, but now we need to highlight number 2 where matrix B is. So highlight 2 and then enter. And now we need, again, 3 for the number of rows, Democrat, Republican, other unaffiliated. And then we're going to need 2 for the number of columns for the 2 responses, yes or no. And now here we're going to enter in the expected values that we just got a few minutes ago. So starting off in the first row again, Democrat, yes, that first entry we said was 43.2. So 43.2, then enter. Then the number of no's we said for the Democrat was 28.8. So 28.8, then enter. And then for the number of Republicans in the second row, yeses was 40.2. So 40.2 and enter. And then the number of no's was 26.8. So 26.8, then enter. Now we are in the third row, and this is for the other unaffiliated. Number of yeses was 36.6. And the number of no's was 24.4. So now we have the observed values in matrix A and the expected values in matrix B. And so now we're going to do something with these values. So we're going to go back to a button that we've used many times before. It's going to be the Stat button. So press on the Stat button. And we're going to go to Tests because we are in Hypothesis Tests. And then go down until you see chi-square test. And there it is. So the chi-square test is what we want. Highlight that and then press enter. And notice you see observed and matrix A is right there. If it isn't, have matrix A typed in. And then expected is matrix B. That's already there. And then you're going to press enter again to go down to the word calculate, so that calculate is highlighted, and then press enter here. And notice what we get. The chi-square value, 3.045, the p-value, 0.218, and then also df, which you might remember is degrees of freedom. So now we have everything that we need to go back to the workbook and answer the questions. Okay, so we got our chi-square value. I'm just going to write it here where it says the chi-square test statistic value. From our calculator we got 3.045. So now let's just answer some questions below where we're going to summarize exactly what we saw from the calculator. So first, as we've seen in typical hypothesis tests, we need a conversation about degrees of freedom. So computing degrees of freedom and computing or approximating the p-value, we already have this from our calculator, but let's just go over these questions. As you know from earlier lessons, p-values are computed from chi-square distributions. The shape, center, and spread of a chi-square distribution are based on degrees of freedom. For a chi-square test for independence, the way that you can get the degrees of freedom would be number of row categories minus 1 times the number of column categories minus 1. In the data presented in Table 1 above, there are 2 categories of response and 3 categories of political affiliation. In this case, how many degrees of freedom will your chi-square test for independence have? So, degrees of freedom, according to what they write above, number of row categories, remember we said 3, so there should be 3 minus 1, and then times number of column categories, which was 2. 3 minus 1 is 2, 2 minus 1 is 1, and that gives us 2. But we already know that. Our calculator told us to. So this is just verifying that. Number 5, imagine that you conducted a chi-square test for independence based on a two-way table with a row variable with 3 categories and a column variable with 4 categories. How many degrees of freedom would the test have now? So here we still take the number of row categories, which is 3, and subtract 1. And then multiply by the number of column categories, which is 4 minus 1. So this gives us 2 times 3, which is 6. So that's just showing you how the degrees of freedom calculation works. But now for us, number 6, for the political film survey, compute or approximate the p-value for your chi-square test for independence. The chi-square test statistic you computed in question 3 and the degrees of freedom you determined in question 4 are what we would use if we were using chi-square CDF, but we already have this, so from the chi-square test, we get that the p-value is 0.218. So as you can see, this is much easier than what we were doing in the previous section. So now finally, a conclusion to end this lesson. Deciding and concluding. The rule for determining whether to reject the null hypothesis in a chi-square test for independence is the same as for other hypothesis tests. This is the rule. Reject the null hypothesis if the p-value is less than or equal to alpha, where alpha is the significance level. Number 7, based on your previous calculations, at a 5% significance level, would you reject the null hypothesis you stated in your answer to question 1? Write your answer in a complete sentence stating whether the p-value is greater than, equal to, or less than the significance level of 5%, and whether you reject or failed to reject the null hypothesis. So if we put this all together, since our p-value, which is 0.218, is greater than alpha, which is 5% or 0.05, what does that tell us? It tells us we failed to reject the null hypothesis. Okay, so now we've made a statement about our null hypothesis. We could also, even though they're not asking us here, we could make a statement about the alternative hypothesis. If we fail to reject the null hypothesis, it means our data does not support the alternative. But instead, let's look at number 8. Think about the claim that you tested, that there is a relationship between moviegoers' responses to the movie and their political affiliation. So here, this is what they are saying is the claim that we are testing. Based on your decision in question 7, do your data support the claim that moviegoers' responses to the movie and their political affiliations are related at a 5% significance level? Explain your reasoning. Include in your answer whether the null hypothesis, political affiliation, and response are independent, was or was not rejected. So, did we reject the null hypothesis? No. We failed to reject the null hypothesis. So let's start with that. We fail to reject the null hypothesis. Which means our data does not support that the political affiliation and response are not independent. That may seem a little complicated to say, so how about we use a different word? Go back to when we wrote our alternative hypothesis. Not independent means the same thing as they are related. So does the data support the alternative hypothesis? No. So the data doesn't support that political affiliation and response are related. And notice how that just answered the question right there. That's what they wanted to know. Are they related? So we failed to reject the null hypothesis. Thus, the data does not support the claim that political affiliation and response are related. So, is there a relationship between moviegoers' responses and their political affiliation? Not according to this data. The data does not indicate that. And that's it. That's a chi-square test for independence. To end this lesson, the secret word is matrix.